Good day, great network enthusiasts. It's another beautiful day here, and welcome to another section of my networking lab. Okay, today we are going to look at dynamic ARP inspection. All right, so that is the topic for today. We are still in layer 2 security section of my lab. So after this one, this is the last one of the layer 2 security section. We'll move to layer 3 security section. That is what we'll be talking about access list. Okay, so before we talk about dynamic ARP inspection, we know it's a layer 2 security feature that is used to protect against ARP-based attacks. So what is ARP? Then how does the attackers manipulate the ARP request and then ARP reply to cause some attacks? Okay, so first of all, ARP is a protocol that is used to learn a MAC address of a known layer 3 address. Okay, so for example, this PC doesn't know the MAC address of this switch, but you know the IP address of the switch. So if you want to learn the MAC address of the switch, it will send an ARP request to the switch. Okay, it will broadcast the ARP request, then include the switch IP address. So the owner of the IP address will now send a unicast ARP reply to the device, that is to the PC. Okay, so how does attackers uses ARP request and ARP reply to cause some attack? Okay, so there's something called man-in-the-middle attack. Attacker can manipulate the ARP request that is broadcast. Because ARP request is broadcast, the attacker in the network can get access to the ARP request, and then he may respond to the ARP request instead of the legitimate owner of the IP address to respond. It will respond on the behalf of that IP address. You will be claiming that it's the owner of that IP address, then it will not send you its own MAC address instead of the legitimate IP address. So it's claiming that it is the owner of that IP address, then it sends you the MAC address of its own. So whenever you want to send the packet to that IP address, you send it to it, because packets are encapsulated in Ethernet header. So you will include the attacker's MAC address in your packet, then the attacker will receive the packet. Okay, so when the attacker receives the packet, it may de-encapsulate it, look at the content of the packet, then it gets the information in it, then it may send it to the original recipient of the packet. Then in this case, it has successfully performed man-in-the-middle attack, because it is interacting in between the source and then the destination recipient. Therefore, it has successfully performed man-in-the-middle attack. Also, sometimes it may decide to keep the packet. So in some cases, dynamic ARP inspection may prevent this, but sometimes if you prevent it, the attacker may deliberately want to punish you by overwhelming your switch with a lot of ARP requests. Every second they keep sending flooding ARP requests. So how do you prevent that kind of attack? You have to decrease the numbers of ARP requests on the interface. Okay, so any interface connected to an end host like this PC, you can configure a limited amount of ARP requests on that interface in a second. Okay, so that is where we use this limit rate. Okay, so without wasting time, I will go straight to the configuration. But before I do that, let me remind you of something here, that this limit rate to reduce the number of ARP requests on an interface is not supported on packet tracer. Then there's still another one that is not supported also. Okay, this ARP ACL is not supported on the packet tracer, but no problem. I will show you that you can still perform it, because I get access to our real network device here, so I will show that in our real network device that the command will be accepted there, but in packet tracer the command will not be accepted. Alright, so let's go straight to the configuration. The instructions are written here. Apologies for the other write-up here. I previously used this lab for DHCP snooping. So ARP inspection, dynamic ARP inspection, and this DHCP snooping work together. So before you enable dynamic ARP inspection, you must configure DHCP and you must have DHCP snooping. If not, ARP inspection cannot work, because it depends on the DHCP binding table created by DHCP snooping. So that's why I have to use this lab that was previously used for DHCP snooping. Alright, so the instructions have been given here. First of all, you have to enable ARP inspection for VLAN 10 here, because the VLAN we are using here is VLAN 10. So I created this VLAN. This will be the VLAN for the end host. My name is Cisco. So let's go to configuration mode with conf t. So the command is ARP inspection VLAN 10. So ARP IP ARP inspection VLAN, let me just question mark, okay, VLAN 10. Okay, we are using VLAN 10, so enable it on VLAN 10. Assuming we have more VLANs, we have to enable it for multiple VLAN, use comma, then you can add more VLAN, use for example 20. Okay, this one doesn't support it. Maybe you have to do it separately. And applying it to multiple VLAN, you create one for VLAN 10, you create one for VLAN 20, and so much more. But we are only having VLAN 10 here, so we got to apply for only VLAN 10. Okay, so just like DHCP snooping, some interfaces are untrusted, some should be trusted. Okay, so which interface should be trusted and which interface shouldn't be trusted? I explained that earlier in the DHCP snooping. Any uplink interface, that is interface facing another networking device, should be configured as trusted. Then the interface facing end host, like all these fast Ethernet 0, 1 to 3, should be configured as untrusted. You don't need to make this one untrusted because by default all interfaces are untrusted by default. So you only have to configure this G01 as trusted interface. So change it from the default mode of untrusted to trusted. Okay, so we have to go to interface configuration mode. Okay, I'm currently in configuration mode, so let me enter interface configuration mode, the interface G0/1. Okay, IP ARP inspection, let me use question mark. Okay, trust. Okay, I'll make this G01 a trusted interface right now. Okay, so I have to enable limit of 30 requests on an interface every 3 seconds. Okay, so what does this mean? Within interval of 3 seconds, if the interface receives more than 30 ARP requests, the interface will enter error disable mode. Okay, that is used to prevent that overwhelming attack of deliberately sending ARP requests every second, flooding ARP requests every second. So one thing about DHCP requests, ARP requests, they cost a lot of work on the central processing unit of the switch. So if you're continuously sending that, you're overwhelming the switch. So it's doing a lot of work processing that ARP request and then discarding, accessing it. So you have to limit that so that if the attacker purposely flood ARP request, then the interface will enter error disable mode. You have to either enable it manually back or error recovery. But I said that earlier that ARP inspection limit is not supported here, but we try to do that. Then later on I'll log into our real switch, that is our physical switch of our network, and then enter the same command and you see that the physical switch will accept it. But let me do that. So I'm currently in interface configuration mode, so let me exit out of interface configuration mode. So I am in global configuration mode right now. So let me do that with IP ARP inspection. Let me use a question mark here. So the only thing it supports here is the validate and the VLAN. Okay, so I will jump this one for now, so later on I will log into our device and enter the same command. Then the next one is validate. Okay, so because if you enable dynamic ARP inspection, the only thing it is going to check is it's only going to check the binding table, DHCP binding table. Okay, so that's how it performs its check only on trusted interfaces. So when it checks this DHCP binding table, what does it do? The thing is going to check in that DHCP binding table is to verify if this IP addresses that is sending this ARP request exists on this DHCP binding table. Is there an entry for this IP address? So is this IP address mapped to a MAC address in the DHCP binding table? So therefore, this showed that if you are using dynamic ARP inspection, you have to have a DHCP configured on the network. That is number one. Then DHCP snooping must be configured on that switch, on that particular switch that you are configuring this DAI. Okay, so that's because DAI depend on the DHCP snooping. Okay, so that's very, very important thing that you need to note there. Okay, but sometimes attackers, they are more advanced than this. They can still, once they succeed in escaping that DHCP binding table, because they may use DHCP to also get an IP address. They can still manipulate the MAC address using another person's MAC address by spoofing the MAC address to match another user's MAC address. So they can also spoof their IP address. So they can easily escape this. You want to perform more in-depth check, okay? So, you know, attackers, they are funny. They get a lot of method of manipulating things. Sometimes they may use fake addresses, like layer 3 addresses. Sometimes you can see attacker behaving funny, like using network addresses. They can use multicast addresses. They can use broadcast addresses to still perform attack. So sometimes there are a lot of things they do. Okay, so the more check you want to perform is using this ARP inspection validate. Okay, you want the switch to, after looking at the DHCP binding table, is to still perform more check that, okay, this kind of address that is sending this ARP request, is it a real genuine IP address? Is it a network address? Is it a truly an end host address? Is it a multicast address? So you perform a lot of stuff like that. That's when you use DHCP inspection validate to perform that IP check. Okay, so if you wanted to perform source MAC address, to perform more in-depth check on the senders of this ARP requests, okay, you have to validate that the MAC address on that IP header is also the same with the MAC address on the body of that ARP message. So when you're sending ARP message, the layer 2 header, we have the source MAC address, and then also in the body of that ARP message, there is another field for source hardware address. Okay, so that source hardware address and then the MAC address on the layer 2 header should be the same. If it is not the same, then the switch will drop it. Then destination address, this one is also similar, but it only check this one when there's ARP reply. So someone that want to reply, okay, I'm the owner of this IP address, so this is my MAC address. So perform the same check on the Ethernet header, that's layer 2 header. You are responding to this ARP request. You claim this is your MAC address, right? So the MAC address in the Ethernet header should be the same with the MAC address in the body of this ARP response. Okay, so that's when you perform more in-depth check, checking the MAC address of the ARP request, checking the MAC address in the body of the ARP message, and then the Ethernet header of the ARP response. Then checking the IP address if it is valid IP address. Okay, so let's go to configure this. Validate question mark. Okay. There's something very important here. If you enter only one, you don't need to enter these different ones one after the other. You have to enter all of them in one line. If you enter destination mark, then later on enter IP address, the IP will override the destination mark. So you have to enter all of them in one line. Okay, so when you are doing this, the order doesn't matter. You can enter source mark first, you can enter destination mark first, you can also enter the IP last in one. Okay, so source dash mark, destination dash mark. Okay, so I've entered this. Okay, so this one is almost done here. The last thing is this ARP ACL. Okay, ARP ACL. Do you know why ARP ACL is very important? Okay, some hosts, for example, this PC, I've configured it using a static IP address. They don't use this DHCP. You have assigned IP address to it manually. It doesn't use DHCP. Okay, so how will it have DHCP binding in the binding table? How will it have DHCP entering the DHCP table? So it's not possible. Therefore, its ARP will not be allowed, will not be permitted by the switch, because the switch will look up to the DHCP binding table and it doesn't have entry for it because its IP was not learned via DHCP. So it can't learn MAC address of any device in the network because its ARP request will be blocked. Okay, so in such scenario, you have to create ARP ACL for that kind of device. Okay, so when you create ARP ACL for that device, when its ARP request reach the switch will use the ARP ACL to check a legitimate device in the network. Then if it succeeds in passing through the ARP ACL, then its ARP request will be allowed to pass through the switch. Okay, but unfortunately this device doesn't, packet tracer doesn't support this command. So let me try to configure the app ACL. So the command start with app access list, then followed by the access list name. App access means question mark unrecognized, app unrecognized. Okay, so you can see the command is not recognized because it is packet tracer. So what I'm going to do next is to log into our physical device and try the same command on our real networking device. Okay, so give me some seconds, I'll do that now. Okay, so as you can see, I'm into our physical device now. So let me enter configuration mode, conft. Oh, sorry, a mistake. Let me enter configuration mode with conft. So the command start with app, right? App, use question mark, you see the various options. Can you see access list now? App access list. Let me use tab to complete. Then let me use question mark, what next? Word followed by the access list name. But mind you, I'm dealing with the reactive device right now, so I'm not going to take any risk. So I'm going to play it. I'm just proving to you that the command really works in a physical device. Okay, so if you want to apply to an interface, to a particular VLAN, that is you have already created the app access list, and then you want it to be activated on a particular VLAN. So the command is IP ARP Inspection. I think filter, right? Let me use question mark. Yeah, filter. Okay, filter. Then followed by the app ACL main. Okay, so let me say I name my ACL as for app. Sorry, app. Then okay, I name my ACL as ARO. Let me use question mark. Then followed by the VLAN. I use it on VLAN 10. Okay, so I can apply it now, but let me not do mistake and hit enter. It's an active device. Okay, so I exit out of it here now. Alright, so let me close it. So the exact configuration have been done. Now let's look at some show commands to validate our configuration. So show command, you can use show IP ARP inspection interfaces to know the interfaces they are activated on and then their state. Okay, then you can also use the show IP ARP inspection to view more information about the configured app, dynamic ARP inspection, then some statistic if there's any validation and numbers of app requests and stuff like that. So let's begin with the show IP ARP interfaces. Okay, show IP ARP inspection. Sorry, inspection interfaces. Okay, so as I configured an IP ARP inspection for on VLAN 10, it's applied to all interfaces, and just as I told you, all interfaces are untrusted by default. As you can see, all the interfaces are untrusted except the G0 one that we manually changed its state to trusted. Okay, so rate limit, this section is for the rate limit. Okay, so by default it allowed only 15 packets per 1 second. So if there is app request more than 15 app in 1 second on an interface, the interface will enter error disable mode. Okay, so it will be shut down. You have to re-enable it either manually or use error disable recovery. Okay, then the burst interval is 1. What is burst interval? Burst interval is that's numbers of seconds. You can change the seconds. Okay, so if you want the 15 packets to be per 2 seconds, then you can change the burst interval to 2. Okay, if you want the packet to be 20 packets per 3 seconds, 30 packets per 3 seconds, 4 seconds. So specifying the burst interval is increasing the seconds. You want the interface to, you want the packet to be received on the interface. Okay, so that's it here. Then let's use the other show command, show IP ARP inspection. Okay, so app inspection is activated on only VLAN 10. So configuration is enabled, operation is active, ACL match. It doesn't allow us to configure the ACL, so there's no any ACL match. So static ACL. Okay, so this static ACL, assuming ACL was configured, it should be in static mode, because if you don't allow static ACL, it will block every other one that are using DHCP's binding table. So if you change this ACL from static mode, that means you are instructing the switch that every device in the network should go through this ACL shape. But if you leave it in this static mode, only the one you configure to be permitted will be checked using the ACL, okay, using the ARP ACL. So the other one will be using the binding table. Alright, so here are the few other information: DHCP permit, ACL permit, and so many more. That's all for today. So at the end of this section, in the next session we'll move to layer 3 security. So that's one we'll be talking about ACR, that is layer 3 security access list. So if you like this video, don't forget to subscribe to my channel, share with friends, comment and like. To have a beautiful day.